So abstraction mechanisms and abstraction methods supposed to be supported by all object-oriented languages, because this is one of the principles. The polymorphic behavior derived from the idea of abstract methods is essentially that you should be able to provide abstract methods at the higher level in your inheritance, and then it just represents some kind of promise, some responsibility. Like, for instance, the classic example would be when you have some kind of drawing application and you have a shape, right? And your shape can be, triangle, circle, and rectangle, right? And so these are specific types of shapes. However, you want to be able to have essentially some sort of class that represents the entire drawing. So say drawing, right? You have the drawing class, and of course in the drawing class you have a collection of shapes, and you can have as many as no shapes or many shapes. And of course over here you have inheritance, right? Because specific shapes represent this generic shape, right? But an abstract method draw inside shape is just a declaration of the draw, but then the triangle, circle, and rectangle will provide the actual implementation of that method. So that's the level of abstraction. So over here, shape only if it has method named draw, it would have no implementation, and it only represents the responsibility of the shape and says that I promise you that when you use shapes, they will have draw method implemented. But then, of course, the triangle, circle, and rectangle will have to implement that method, right? So that means that implementation is happening, and it has to happen through a non-abstract method. And it's just very basic type of functionality that we say that with inheritance we have an ability to use abstract methods and non-abstract methods, and all of them can be used together. So abstract method is overridden in descendant classes, in subclasses of the superclass or base class, and for each responsibility, a corresponding capability has to be provided, and constructors cannot be abstract. This is just something to remember, that constructors are not inherited, therefore they cannot be abstract. In other words, if I provide a constructor method to a shape, the constructors are not inherited by triangle, circle, and rectangle automatically. And because they're not inherited, constructors cannot be abstract. So that's one of the reasons why constructors cannot be abstract. But also constructors, having abstract constructor would be somewhat unproductive, because constructor supposed to populate, its responsibility is simply to populate the object with initial information. Therefore, having it declared as empty method with no implementation simply doesn't make sense. So constructors cannot be abstract, right? So sometimes, again, in a job interview, someone could ask you, can constructor be abstract in Java? The answer is no, because it doesn't make sense and it's not part of the language design. All right. So abstract classes are any classes that already contain abstract methods, right? So we have a class document. Class becomes itself abstract if it has any abstract methods, and that's the case, right? So sometimes you can say over here, if I actually enlarge the view of my shape over here, right? So sometimes people simply say abstract shape in their diagramming, right? Just to indicate that this is an abstract. Sometimes Sometimes, so there could be different variations of what people do to show that it's abstract. Another possibility is that they take the shape, okay, and place it inside the angle quotes like this sometimes to indicate that shape is abstract. So these types are notations also exist, and sometimes they simply use italics, right? Shape. Use italics italics fonts to indicate that it's abstract. So choose whatever works best for you. But this is kind of popular to use angle brackets, to use this quotation around the name of the class to indicate that this is an abstract class. Abstract class, of course, is the class that has abstract methods, and any class that has abstract methods cannot be instantiated. Okay, the compiler will simply say, I don't have enough information to create an object of this kind. So therefore, the clients of the system have only a choice to create triangles, circles, and rectangles, but they cannot say new shape. Compiler will reject that type of idea and say that you cannot instantiate class that is abstract. All right. So moving on, but an interesting part of it is that it still doesn't mean that the shape, although abstract class, cannot have a constructor, right? Because remember, when you construct a triangle, if you don't do anything, a default constructor of shape is still invoked, right? Or you can provide your own constructor, which can be default or not a default constructor, so that despite the fact that abstract classes cannot be instantiated, they can still have constructors invoked by the derived classes. So just be aware of it. So abstract classes can still have constructors. That's not a violation of anything, because remember, when circle is created, its shape part is also created, and therefore its constructor can be run. However, the shape of its own cannot be created, even if it has the constructor. And we can actually, we could have written a small application to try to experiment with this, but I would encourage that maybe you experiment on your own to play with constructors inside abstract classes. All right, abstract methods and classes in C++. So in Java, the keyword is abstract. In C++, the keyword is virtual. Okay. And something else to say abstract keyword or virtual keyword in C++ and abstract keyword in Java is that you can also, in addition to what we just said, you cannot have abstract data. The data is always concrete. Because what does it mean for me to say, abstract integer x? It just doesn't make sense. Integer means that I want to have an integer in memory. An abstract integer in memory, it's almost a contradiction with an idea. Let's have an integer thing and have it abstract. Abstract means that it doesn't exist, right? It will exist later. So these the abstract and data attributes don't. These two concepts really don't fit too well with one another, and so this is not possible. You cannot declare data attributes inside shape class abstract. All data attributes are concrete and normal data attributes. They're not abstract and cannot be abstract. Again, it would be interesting to have a small project where we would attempt to declare an integer an abstract and see what kind of error compiler will give us in both, say, C++ and Java, just to see what the result is. Perhaps we can try this very quickly.